Okay, let's go through this question 9 together that you are struggling with. So we've got here that it's a normally distributed with 260 millilitres mean and standard deviation of 6 millilitres. So if we are to draw our little diagram to show that we know what that means, we've got our normal distribution with a mean of 260, standard deviation of 6, and it says container less than 250 is underfilled, so we've got our 250, all of this is underfilled, so find the probability it's underfilled. So on our calculator we do distribution, normal CDF, lower as that'll do, upper is 250, mean is 260, 6 for standard deviation, and we get an answer of 0.0478. Okay. Okay, to solve this next problem, because we're changing our standard deviation, the best way to be able to solve these problems is to use the equations that we have for our standard normal distribution. So we're going to use a standard normal, and you know with standard normal that we have a mean of 1, mean of 0, standard deviation of 1, okay, and we want to leave the mean unchanged. We've got to find the z value that goes along. So the z value is the value on the x-axis that would relate to our 250 if we were using our non-standard normal. Okay, we have our probability of 0.02 now. So if we do our normal distribution, okay, doing our inverse normal because we know the probability. Inverse normal, area this time is 0.02, mean of 0, after that, so we get a z value of minus 2.0537, okay, 5375 actually. Then what we can do is use our formula that we have for standard normal. Okay, so when we have a value probability of a value there with a normal distribution, mean, standard deviation like this, we have the z value is equal to the value minus the mean over the standard deviation. Okay, so what we have now is that we've got our minus 2.05375 that we worked out on a standard normal. Okay, we've got the value underfilled is still 250. That hasn't changed, and we've got minus the mean of 260 is still the mean, all over whatever our standard deviation is. So we've used this value from our standard normal, so it will still apply. So then we do a bit of rearranging, so I've got the answer minus 10 over minus 2.05375 equals standard deviation, and that works out at 4.869. Okay, so there's our new standard deviation. Okay, so we've got our new standard deviation and leaves the mean unchanged. So that is now 4.8. So let's use that value, 4.87. Leaves the mean unchanged, still 260. Container shows it running for inspection. Okay, so again, using my little curve to show what I'm doing. We've got to find the probability that it was between 250 and 271. So calculator, back to normal CDF, lower bounds 250, upper bounds 271, mean is still 260, standard deviation is now 4.87, and we get a value of probability of 0.968. Okay. Part B, given that the container is not underfilled, so it's this given that we need. So remember, we've got this equation, A given B is the probability of A and B divided by the probability of B, so the given that one. So in this case, the probability that it passes inspection, B, is from the previous part of the question. Okay. So the probability that it passes inspection is the top half. So we've got that from before. So that would be 0.968. Then what we've got to work out is the given that. So given that probably is not underfilled. So we've got to work out the probability of not underfilled. Okay? So that's what we need for the denominator. Okay? So so the probability of it not being underfilled is obviously all of this side, right? So we could go through and redo it. Normal CDF, this time the lower is 250, the upper is 1 times 10 to the 99. Still got the same as that, so we've got a value of 0.97998. So if we do that, we get a value of 0.988, basically. We do that divided by that. So just to recap, so this is the probability that it passes the inspection. So we did that in the previous bit. Given that underfilled is what it goes underneath, so we needed to work out the probability that is not underfilled. We have this from before, but with a different 0.02, wasn't it? So we could have done it that way as well. 1 minus 0.02. But I've got a slightly more accurate answer doing it with my calculator. Okay, so 1 divided by the other gives me the probability, given that. So it's that formula, probably in your formula booklet. Right. Finally, a sample of 50 containers chosen around, find the probability at 48 more pass. So it's either pass or fail. So that means we have to remember that we have a binomial probability now. So what we are looking for, so part D, is this notation, binomial, where we do 50 trials, so 50 containers, and the probability of it passing was the previous question, 0.968. So we've got that as our notation. If we were to work that out on our calculator, so second distribution, binomial, CDF, trials, 50 trials, probability that we want is 0.968. Now the X value, it says probably for 48 or more, right? Now remember the calculator only does from less than and up. So I'm using normal, but remember, so if we want a situation where we want 48 or more, the calculator's going to work that way, and because it's pots of yogurt, if it's not 48 or more, we have to work out 47. So the X value here needs to be 47, because there's no 47.5 yogurt pot. So we paste that, so we get a value for this side of 0.2149. So then we obviously want the other side because it's more than. So we've got 1 minus 0.2149, which equals 0.78. So that's that probability. So as normal with these questions, you've got both distributions in there. You've got normal distribution, you've got binomial distribution, just to finish that off. So you will expect both of those to come up normally. Okay, let me know if you need any more explanation. I would suggest this whole over here using the standard normal is something we didn't maybe do enough of, that you need to use and remember these formulas and how we can use it. So this Z value was found using standard normal, but it still applies with the values of the actual values. Okay.